Hey guys, my name is Jason with Non-Baker Mining and Metals, and on today's video, we're going to be crushing up some oyster shells for one of the biggest shellfish processors on the West Coast. They've got literal mountains of this stuff. They're interested in making a product out of their waste shell. They've got to get them crushed up to the right size first. So these are oyster shells they sent to us, but in the past we've done oyster shells, we've done clams, we've done mussels, we've done crab shells and lobster shells. So this is a really big industry actually, this crushing up of these waste shells. This company is after a product that looks something like this. I believe this is for chicken feed. They use this to supplement the chicken diet for calciums for their eggshells. And so this is what we're going for. But the problem with hammer mills and jaw crushers is they're great at sizing a top size, so like a 1/2 inch minus or a 3/4 minus, but they're not good at sizing on the back end or the downside. So we can get a product that's no bigger than this, but there's definitely going to be some smaller stuff in there. So let's look at some of the screens we're going to use today in the hammer mill in particular. I've got two different options. This is a 3/4 inch hole here. If that doesn't work or that gets too big a size, I've got a 1/2 inch slot. And I can go smaller, I can go 1/4 inch or, holes or slots or squares, whatever they need. But these are the two I had on hand to run their sample. And my thought is that even if you get a little bit oversized through these holes, most of it is going to be in this size range that we're looking for. And you don't want to overcrush it. And the finer you get, the more fines you're going to have. So I would rather try and put that bell curve of sizes out of the hammer mill right at the peak, right at this peak, which is going to be a little bit oversized, a little bit undersized, but most of it in this range. Well, they have the lid off now. I wanted to show you what the inside here looks like while I got it off. And looking up in there, there's the feed chute. And we've got replaceable armor all the way around for wear surfaces. These two up here get worn the most, actually. Side armor here that is all bolt-on and replaceable. And as you can see, it comes really pretty clean. I mean, I was running this yesterday with some gold ore in it, and it's not like there's a bunch of sand and muck and stuff all stuffed up in there. So it comes pretty clean. Here's the rotor assembly of the mill. This is right here is the wear surface of the hammers. So you can see that. These are fairly new. I've probably run maybe a couple tons through here. But you can see they don't wear very fast. I mean, I'm going to get several tons. I'm going to get 20 or 30 tons out of these set of hammers before they wear out. And oftentimes what will happen is the leading edge here wears down and rounds real bad. And then you can take the hammers and turn them around and you get a whole nother surface on this side. So you run for 15 or 20 tons, turn the hammers around, and get another 10 tons out of them. There's the screen. It wraps all the way down underneath and comes up to a stop here. Okay, our screen's in there. We're all set to go. I don't know if I mentioned earlier, but these are chrome iron hammers. They're about 20% chrome, and they're extremely abrasion resistant. So that's what we use for general aggregate crushing, or oyster shells, stuff like that, glass, recycling glass. And then for the electronics and the PCBs and the recycling and stuff like that, we use manganese steel hammers for those. right, well, we got the jaw crusher and the hammermill sample run. And we're going to start with the jaw crusher. This stuff actually came out a lot finer than I thought it would. There's a lot of powder in here. So what I'm going to do is I'm going to take this stuff, and I've got 3 different size screens here. I've got a 1/2 inch, a 1/4 inch, and an 1/8 inch. And so we're going to screen the shells through these 3 different fractions, 3 different screens, and see what percentage of each size we get. Here's the screen results from our jaw crusher sample. And starting over here with the largest, this is the 1/2 inch plus. And it's really pretty nice looking stuff. That would make great landscape mulch. Then moving over here, this is the 1/2 inch to 1/4 inch. And that is also really nice looking stuff. Again, landscape mulch probably. I'm sure there's an application for that. This is the 1/4 inch to 1/8 inch. And I think this is probably the closest that we came to the customer sample. I'll show you that here in just a second. But this is kind of what they were shooting for, I think. So that's that pile. And then this is the 1/8 inch minus. So it goes 1/8 inch all the way down to powder. And that's really nice looking stuff. And I don't know if that's like a fertilizer product, soil amendment, you know, add it to compost or whatever. So there's the 4 piles. And amazing to me, again, I'm really surprised how well the jaw crusher did, but all these piles are about the same volume roughly, I believe. And so you get a really nice even distribution of sizes when using the jaw crusher. In my hand here is the sample set from the customer. And there's the pile of stuff that's 1/4 to 1/8. So I think it's pretty much the same stuff. And here's the screen results from our hammermill with 3/4 inch holes. And you can see right away that there's hardly anything up here on the 1/2 inch plus side. And the most material is down here on the 1/8 inch minus. So I mentioned earlier about that bell curve, and this is a good representation of that bell curve from the jaw crusher. It's like it went up and was plateaued across all 4 sizes. Whereas with the hammermill, the bell curve has been shifted over to the right. So it kind of ramps up here, and then you have the most volume in the fine stuff. I don't know if that makes sense to anybody, but hopefully you understand what I'm trying to explain. But again, this is the same size fractions, 1/2 inch plus, 1/2 to 1/4, 1/4 to 1/8. This is the range that the customer was looking for. And then 1/8 inch minus. Today we're going to be demonstrating one of our oyster grinding machines behind me. So we've got our hopper full of oyster shells here. They're all mucky and gooey and wet. We're going to turn the vibrator on. We're going to feed out this chute here into the spiral conveyor. We're going to go up into the hammermill. We're going to add about 2 or 3 gallons a minute to the hammermill to help flush it out. And it's going to discharge through the 3/4 inch hole into the barrel. And this is for any oyster shell, clam shell, anything from processing that guys end up with huge amounts of shells and stuff. This is a better system that you run the materials through, grind it up, and chicken feed, mulch for landscaping, soil action, calcium stuff. So anything that really grinds stuff up and use it for is a huge bonus for these guys, because right now they have mountains of waste and a lot of times they can't do it. So here's the results from our oyster test. And we ran about a cubic meter or a cubic yard in about 10 or 12 minutes to give you an idea of the volume. This was a 3/4 inch screen, round holes. If you're interested in a smaller size than this, we can certainly make smaller holes at 1/2 inch or even 1/4 inch, or bigger holes. And by adjusting the hole size up or down, it's going to play with the throughput a little bit. But yeah, I think it was a real successful test. It went great. Everything fed right through the hopper nice and even. Today we're going to be running another sample of oyster shells, and we're going to be running through a 16 by 12 hammermill to test with. It's got a 1/4 inch by about a 3.5 inch slotted screen in it. And the goal is to grind this stuff up for chicken feed and stuff like that for this customer. So we'll take a look at the sample and then we'll get started. All right, this is the sample we're going to be running today. And these are the shells, and this is going to be a little bit different than the past ones we've run because these are dry. Normally, if the oyster shells are damp or wet, we need to add water to the mill, but because these are all dry, we're going to try running them dry, so the product will be dry and can be bagged and be sold directly out of the mill. So here's the results from oyster shells through the hammermill, and I think the test went really good. This can actually be directly bagged and sold for chicken feed right out of the hammermill. It doesn't need any further reprocessing. Today I wanted to show off one of our new products. This machine is for grinding oyster shells, and it was commissioned by one of the largest shellfish producers in the state. And so I wanted to walk you through the machine, show you how it works. So this is the feed side of the machine. You can dump a whole skid steer bucket of oyster shells in the hopper. There's a cleated belt that drags the shell up and feeds into a 16-inch by 12-inch hammer mill. Okay, we're on the other side of the machine now. And this is the top of the cleated conveyor belt that drags the shell out of the hopper. It comes down into the hammer mill here. This is a 16-inch by 12-inch hammer mill run by a 15-horse electric motor. The shell is crushed and goes through the 3/4-inch punch plate screen and out this discharge conveyor, and it can either be discharged into a pile, onto a trailer, or into a small dump truck. So here's some of the shell we're going to be crushing today, and this is processed shell, so it's been sitting out. They've cleaned it. There's even some big clusters like this where a couple shells stick together, but this is the fairly easy stuff to crush. There's some other stuff called green shell, which is fresh right out of the salt water. That it's in little bigger clumps, has some junk on it, some rocks with it. So we're going to try both types today and show you how each one crushes. And this is used for all kinds of stuff like chicken feed, soil amendments, fertilizer. They use it for landscaping mulch, bocce ball courts of all things. Here's a look at the green shell that we crushed. You can kind of get an idea for the size that comes out of there. And here over on the edge here, there's some of the bigger pieces. So it's all 3/4-inch minus, but there's quite a bit that's less than 3/4. And we can crush one of these blue totes in about 10 minutes. And I think these weigh about 500 or 600 pounds a piece. So that kind of gives you an idea of the throughput. And this green shell was quite a bit different than the processed shell. It had big chunks of wood in it, rocks, sand. The oyster shells were all slimy and clumped together. But it didn't seem to matter in the hammer mill. It took it just fine and crushed it all down and discharged out the conveyor belt. So even the green shell crushed just great through the system. So that's kind of what the product looks like. And again, when you change those screen sizes, either bigger or smaller, you can get a little bit of finer grind or a little bit of coarser grind. Today we're going to run a sample of these mussel shells. And the goal today is to get these through a hammer mill with no screen. And we're going to crush them down for volume reduction. We're going to be running them through one of our 16 by 12 hammer mills here. 15-horse, 3-phase electric motor. There's no screen and no hopper, so the material will fall right out the bottom into this bin, and we'll see how much we can reduce the volume. So here's the results from our mussel shells through the hammer mill. And as you can see, we accomplished exactly what the customer was after. We took 4 heaping 5-gallon buckets full of mussel shells, and we reduced it probably by 50 to 60%, or maybe even a little bit more. And even the rocks and the shells, everything went through great. And this is really a pretty good result. Today we're going to be running a sample of these oyster shells. And the goal here is to crush these up and liberate this rope so it can be hand picked out from the shell after it's crushed. So now we're going to try oyster shells with rope attached through one of our 16 by 12 hammer mills with no screen and see how that works. Right now we're working with one of the largest oyster growers on the West Coast to help solve their issue with this rope, which they're telling us is one of the biggest environmental problems that they have in the industry today. And they're looking for a primary crusher to liberate the rope in the shell, and then a secondary crusher that's going to take the broken shell with no rope and crush it down to fine powder so they can use it in their growing operation. So here's the rope and shell after the hammermill. The rope came clean. It didn't roll up or bind up in the hammermill at all because there wasn't any screen. The shells, I think, actually got crushed a little bit finer than through the jaw crusher. So I think overall it was a great test. I hope you guys enjoyed the video. If you have any questions or comments, please let us know. You can find our contact info in the description below. So thanks for watching, and we'll see you on the next one.